Hello, this is a series, most likely 3 videos. This is the first of the 3 on complex numbers, imaginary numbers. This first video concentrates just on the arithmetic between these numbers. So a complex number has a real and an imaginary part. These are both real numbers. A and B are real numbers. The letter I is going to stand for the square root of -1. We're now going to allow negatives underneath the square root. This first question is more like just combining polynomials. You have things that look alike get combined. At first glance, this looks like multiplication because you see the parentheses, but in between these two is a subtraction sign. So we'll take 3 and subtract 2. That'll be the real part. We'll take -2i and subtract -3i. That'll be the imaginary part. Reals with reals, imaginary with imaginary, we put them both together and you have your new number. So 3 minus 2 is a 1. This double negative is a plus, but the integer arithmetic on the coefficients leads you to subtract because the signs are different. 3 take away 2 is 1. And so we get the result of 1 plus I for the first question. Now the second question has negatives underneath the square root. And now they're allowed. Here's how we handle them. We take this -25 and we make it 25 times -1. Why? So that we can take the square root of each one. With the square root of -1 being I, we have square root of 25 is a 5. So the square root of -25 is 5i. And then we subtract the square root of 16. That's just a real number. That's a 4. Here comes another imaginary number. Square root of -9, we write that as 9 times -1 so that we can take the square root of each piece, leaving us with a -3i. And then finally, once again, we have the negative square root of a positive number, so that's just going to be a -2. We're not done. We have to combine like terms. The -4 and the -2 combine to be a -6. The 5i take away 3i combine to be 2i. Okay, more number 3 here. Now we don't have perfect squares anymore. You notice that everything underneath the square root, numbers-wise, was a perfect square. Not the case in number 3. Same concept though. You take 8 times -1 and you take the square root of each one. You take 12 times -1 and you take the square root of each one. 18 times -1 and you take the square root of each one. 27 times -1 and you take the square root of each one. The square root of 8, you got to find a perfect square that goes into it, and then you break it up into the square root of each. Square root of -1, that's an I. Square root of 4, that's a 2. So this is 2 root 2 I. Plus in between, square root of 12. 12 is 4 times 3. And then we're going to take the square root of 4 and the square root of 3. So that's going to give us 2 root 3i. 9 times 2 is what 18 is. Why 9? So that we can have a perfect square. And that's going to be 3 root 2i. Everything is added in this question. And then finally, root 27, that's 9 times 3. And then we'll root the 9 and root the 3, giving us 3 root 3i. Now what we're going to do to combine these is combine rad 2's with rad 2's, giving us 5 of them, 5 rad 2i. And then we have rad 3 with rad 3. Combining those, we'll have 5 rad 3i. And we can just leave that answer like that. There's no combining. We could factor out the I. Let's just leave it like it is. So we've subtracted, we've added. Now we want to look at multiplying. And we use the acronym FOIL, where we take the first 2 times 2. Then we take the outer 2 times 3i. Then we take the inner negative 3i times 2. And then we take the last negative 3i times 3i. Okay. So we get a 4 and a 6i and a negative 6i. Now we have this last term, who is a negative 9, but then I times I is I squared. And if I is equal to the square root of negative 1 and you square both sides, what you end up with is I squared equals to negative 1. Whenever it shows up, replace the I squared with a negative 1. That's multiplied. That's negative 9 times a negative 1, so that's plus a 9. Together with the 4, what we're going to have is 13. Why no imaginary part? Is because they canceled out. 13 is the answer to that question. Okay. Doing great. Let's do 4 more. Squaring a number is multiplying it by itself. If it's a binomial, we can use the acronym FOIL again. First, 2 times 2. Outer, 2 times 3i. Inner, 3i times 2. Last, 3i times 3i. We get the 4, a 6i, another 6i, no cancellation like in the last one. And then here once again is our 9i squared. I squared, remember, is a negative 1. That's multiplied by 9, so that's a negative 9. The 4 together with that negative 9 give you a negative 5. The imaginary parts combine like a polynomial. Coefficients add up to be 12, and it's on I. So we've added and subtracted and we've multiplied. Now we want to look at dividing. You cannot have the square root in the denominator. You know, I is equal to the square root of negative 1. And so I squared is equal to negative 1. And that's what we're going to do. When we're dividing, we want to divide by a real number. And so this imaginary number here we can't divide by. We want to divide by at least a rational number, and so to get that to go away, we need to multiply by a clever version of 1. Why I? Because I squared combines to be a negative 1, no imaginary part at all. Whatever we do to the bottom, we have to also do to the top. The numerator, the top, is negative 2 times I, while the denominator is 5i squared. Remembering that I squared is negative 1, we get negative 2i over negative 5. And you can drop the negatives and call it 2i over 5, or you could actually write the fraction as a multiple on I. Both answers are acceptable. And so when dividing by an imaginary number, you want to multiply by something that will get rid of the imaginary part. If you have 3 minus 2i, the something that you multiply has a name when it's a number that has both the real and the imaginary part. Is called the conjugate. It's the same numbers on the left and right, but an opposite sign in between. Why? It's like having the difference of squares. It's like having a plus b and a minus b. Sorry, I don't know what happened there. There we go. It's like having a plus b and a minus b, or x plus 7 and x minus 7. What happens is the middle terms cancel each other out. We get the 3 times the 3, the 3 times the 2i positive, the negative 2i times the 3, and then the negative 2i times the 2i. So multiplying by the conjugate will accomplish the goal of eliminating the imaginary numbers. We'll have a 6i, and then we'll have a negative 6i. Those two guys will cancel each other out. We'll have a negative 4i squared, which is plus 4. Remember, I squared is negative 1. And then it's 9 plus that 4. Final result would be a 13. Now, we do that to the denominator with the goal in mind of getting rid of the imaginary numbers. But whatever we do to the denominator, we have to also do to the numerator. Okay, that's going to change the look of the numerator, but still end up with our desired format of not having a imaginary number in the denominator. We've just FOILed out the denominator and got a 13. That's our new denominator. Numerator, we'll FOIL that out. Get a 6 and a 4i and a negative 3i and a negative 2i squared. Sorry, it keeps jumping like that. These i's combine to just be a single i. I squared, remember, is negative 1. So that is like having a plus 2. So we get 8 plus I all over 13. Okay, I think this is a good place to stop. That's all the arithmetic. Now we're going to see how the imaginary numbers will come up in factoring or solving an equation. That'll be on the next video.